Ansible for Cloud, Configuration Management. In this tutorial, we'll explore how Ansible simplifies cloud automation and configuration management across multiple cloud platforms. Ansible has become one of the most popular tools for managing cloud infrastructure due to its simplicity and powerful capabilities. Ansible is an open-source automation tool specifically designed for configuration management, application deployment, and task automation. What makes Ansible special is its use of YAML playbooks, which provide a simple and human-readable way to define automation tasks. Unlike many other tools, Ansible uses an agentless architecture, meaning it doesn't require any software to be installed on the target machines. Instead, it connects to remote systems using SSH, making it lightweight and easy to set up. This makes Ansible particularly ideal for managing cloud infrastructure at scale, where you might need to configure hundreds or thousands of instances. Let's understand the 4 key concepts in Ansible. First, the inventory is a list of managed hosts and groups that defines which machines Ansible will control. Second, playbooks are YAML files that define the automation tasks you want to execute. Third, modules are reusable units of automation code that perform specific actions like installing packages or managing files. Finally, roles provide an organized way to collect related tasks, variables, and files into a structured format, making your automation code more maintainable and reusable. Here's what a simple Ansible playbook looks like. Every playbook starts with 3 dashes at the top. The name field describes what this playbook does in this case: configure web servers. The hosts field specifies which machines from your inventory this playbook will run on. The become directive set to yes means Ansible will use sudo privileges to execute commands. Under tasks, you define the actual work to be done. Each task has a name for documentation, and then calls a module. Here, we're using the apt module to install Apache 2 web server with the state set to present, which means the package should be installed. Ansible provides dedicated modules for managing Amazon Web Services resources. The EC2 Instance module allows you to create, modify, and terminate EC2 instances. The S3 bucket module helps you create and manage S3 storage buckets. For security, the EC2 security group module lets you configure firewall rules and security groups. Finally, the EC2 VPC net module enables you to create and manage virtual private clouds and networking components. These modules abstract away the complexity of the AWS API and provide a simple interface for infrastructure management. Let's look at a practical example of launching an EC2 instance. This task uses the Amazon.os.ec2 instance module. We specify a name for our instance: web-server-01. The instance type is set to t2.micro, which is a small, cost-effective instance size. The image_id parameter specifies which Amazon machine image to use. This is the operating system template. We define the region as us-east-1, specify the SSH key pair name for secure access, and set the state to running to ensure the instance is started. With just these few lines, Ansible handles all the API calls needed to launch and configure your EC2 instance. Ansible also provides comprehensive support for Microsoft Azure. The Azure_RM_virtual machine module manages Azure virtual machines, allowing you to create and configure VMs with specific sizes and configurations. The Azure_RM_storage account module handles Azure storage accounts for blob storage, file storage, and other data storage needs. For networking, the Azure_RM_virtual network module creates and manages Azure virtual networks. Finally, the Azure_RM_resource group module manages resource groups, which are containers that hold related Azure resources for easier management and organization. Google Cloud Platform is also fully supported by Ansible. The GCP_compute_ instance module manages compute engine virtual machines in GCP. The GCP storage bucket module creates and configures cloud storage buckets for object storage. For networking, the GCP compute network module sets up VPC networks to isolate and connect your cloud resources. The GCP compute firewall module manages firewall rules to control traffic to and from your instances. These modules follow the same simple YAML syntax, making it easy to manage multi-cloud environments with consistent automation code. Dynamic inventory is a powerful feature that automatically discovers your cloud resources. Instead of manually maintaining a static list of IP addresses, Ansible can query your cloud provider's API to get the current list of instances. This example shows an AWS EC2 dynamic inventory configuration. The plugin is set to amazon.aus.aus_ec2. We specify which regions to query, in this case, US-East-1 and US-West-2. The Filters section lets you limit which instances to include based on tags. Here we're only including instances tagged with environment:production. Finally, Keyed_groups automatically organizes instances into groups based on their tags, making it easy to target specific sets of machines in your playbooks. Let's cover some important best practices when using Ansible for cloud automation. First, always use Ansible Vault to encrypt sensitive credentials like API keys and passwords. Never store them in plain text. Second, organize your playbooks using roles to promote code reusability and maintainability across different projects. Third, always test your playbooks in a staging or development environment before running them in production to avoid unexpected issues. Finally, use tags to enable selective task execution, allowing you to run only specific parts of a playbook when needed, which saves time and reduces risk during updates. Variables and templates make your playbooks more flexible and reusable. In this example, we define variables under the vars section. App_port is set to 8080 and env is set to production. These variables can be referenced throughout your playbook. The template task demonstrates using a Genia2 template file with the extension J2. The template module processes this file, substituting any variables with their actual values, and then copies the resulting configuration file to the destination path on the remote server. This approach allows you to maintain a single template that works across different environments by simply changing the variable values. Let's summarize the key points. Ansible simplifies cloud automation through its agentless architecture, eliminating the need to install agents on every machine you want to manage. You should use the cloud-specific modules provided for AWS, Azure, and GCP to interact with cloud APIs in a simple, declarative way. When starting with Ansible, begin with small, simple playbooks to learn the basics, then gradually scale your automation using roles and dynamic inventory as your needs grow. With these fundamentals, you're now ready to start automating your cloud infrastructure with Ansible.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.